Hey guys, hope you're having a good day. I'm just going to take you through a couple of important things before you run through the simulation today. During the simulation, you're going to be looking at recharge rates and how wells affect groundwater. So first thing I want to do is just quickly review the water cycle. You guys should have a formative posted in the April 1st folder. Getting my days mixed up. Um, and if you haven't taken that formative, please stop video and take the formative really quick. I want to get a good gauge of where you guys are at. So water cycle, we did this when we were talking about food systems and we talked about watersheds. So your watershed is going to be that drainage basin or where how the water flows from the highest peak to the lowest peak within your watershed or an area. And let's just go real quick through how water cycles from evaporation. So I'm going to put a little X where I'm going to start and take you guys really quick through the cycle and kind of highlight the parts that really impact surface water and groundwater because that's what we're going to focus on today. So the sun heats up water. So ocean is a great example of surface water, and then the water becomes water vapor and you can see it moves up, and when it hits a certain point in the atmosphere it gets really cold. That causes the water vapor to condense into clouds. So that's your condensation. We move over here and eventually once those clouds become saturated they'll start to fall to the earth as rain, which you guys can see heads down this way. And then precipitation can be rain, it can be snow, and once that precipitation hits the ground, there's a couple of things or different ways that it can go. If it is hitting the ground and actually goes into the ground and down into the under layers or below the surface of the earth, that's what we call infiltration. There's various terms. Sometimes you might hear percolation or percolating like the coffee pots, or seepage, but basically the water is going from the surface layer down into the groundwater. The other route it can follow is it goes into runoff. So runoff, it can go runoff into a stream, it can run off into the ocean. There's also impervious surfaces. Impervious means that water cannot penetrate it. So a lot of the times if you have an impervious surface like a road or cement, that will also run off into a local waterway. And then the last thing that we haven't mentioned, I'm going to put a little star. Evapotranspiration or transpiration is when you have water vapor released by trees, which is part of photosynthesis and goes up into the atmosphere, which brings us back to condensation. All right, so that's a quick review of the water cycle. Now we're going to talk about the difference between surface water and groundwater. Okay, so surface water, groundwater. This is not going to be difficult. It's actually really straightforward. Surface water is water that's on the surface of the earth or on the ground. Groundwater is water that has penetrated into the soil, into whatever ground you're standing on, and actually goes down into what we will call the water table or aquifers. We'll get into that in a little bit. But surface water, you can see there's surface water right there. Examples of surface water are rivers, oceans, streams, seas, lakes, springs. You guys could probably name some things that I haven't put. I think I missed creeks. Surface water is recharged by precipitation runoff, snow and ice melting, or springs that can come up from groundwater. This is a really important thing to know. This is one of the connections that connect groundwater and surface water. So if you've ever heard of a spring-fed lake, that is the connection where a spring comes up from the groundwater and actually supplies the stream or the lake with its water source. And then the other type of water we're talking about is groundwater. So again, that's the water that has penetrated into the ground itself. The primary example of groundwater is called an aquifer. An aquifer is basically a giant underground lake. Common way of it being described as a large underground reservoir. And the way that that water gets down is by infiltration, which we talked about up in the water cycle. So I have a couple pictures you guys can see. And we talk about something called a recharge rate. That's how fast the water actually recharges. And we're going to talk about groundwater recharge. So you guys can see, these are some pictures that I took on Sunday, March 29th. I was walking along in my neighborhood on a bike path and I saw some standing water. And I just want you to think about, why is the water standing? So this is after we got a couple inches of rain, and you guys can see this area right here in this picture is flooded. And then right along here, this is flooded. This is a road, and then over here you have a parking lot that goes to the railroad station. Why would these areas be flooded? Think about that for a minute. We'll talk about why that happens. Okay, so looking at this first picture, you guys see you have this road. Water's going to run off down into this area. Same thing from this parking lot. If you ever go driving on a highway, you might notice that a lot of highways in the middle or in between the two medians have a lot of native prairie plants, or they have like a little ditch for water to run down into. That's because the roads, if they don't have an area for water to collect, they're going to flood. So this is a little area in which water can run off into. And using these natural features like wetlands where water can collect is becoming more and more popular, especially when they are constructing roads. In the second picture over here, you guys can see this area is just completely saturated. This goes back to our watershed lesson. If you guys can see right there, that's a hill and the water is collecting at the lowest point here. And this ground is just absolutely what we call saturated. It is just completely jam-packed with water that it can't absorb anymore. So let's talk about how those things affect recharge rate. Okay, so recharge rate again is how fast the water is going to penetrate or permeate from the surface into the ground. Three things that primarily affect the recharge rate are going to be the amount of water or the amount of precipitation that's falling, the permeability. So you guys hopefully think back to when we had the gravel, the sand, and you guys were pouring water down into the permeable tubes and saw how fast the water ran through those different forms of soil. And that is something that can affect how fast water permeates through the soil or through the bedrock when you get down low enough. And then there's also the level of the water table. Okay, so this is the big concept that we've been working towards. The water table is, if you look in the diagram here, let me pick a better color that you guys can see. Right there, that's the water table. And the water table is the level at which the ground is saturated or soaked with water. So you guys can see you have your surface in that diagram, and then you have a few feet or a few inches down, you have the unsaturated zone. So this is land that has water, but it's not saturated. So it's not soaked through with water. So if you think of like a washcloth, if you have a washcloth and you wring it out and it's just a little damp, that's like your unsaturated zone. Now, if you take a washcloth or even a sponge and completely soak it full of water and it's dripping, that's what the saturated zone is. It's just completely soaked up with water. So the water table is kind of that top boundary of that saturated zone. And underneath that, you'll find groundwater. So you guys can see the diagram there. The water level or the water table, when we're talking about groundwater, is going to be the top of that saturated zone. But let me point out, when you go into the stream over here, the water table is at the same level of surface water. So the water table is at the top of any body of water, so the top of a river, top of a lake. But when we start moving into the ground itself, that's when it depends on that saturation zone. Okay, you guys are going to move into doing a simulation that is going to look at how water penetrates and feeds streams and how wells can affect this water table or the saturation zone. Okay, if you guys have any questions, please feel free to contact us. Hope you guys have a great day. Bye.